I can write that as y equals 8x to the power 1. You agree? It's the same. So now I'm going to differentiate. My rule is the same. So dy dx. So it's going to be 1 times 8x to the power. What's 1 take away 1? 0. Okay? But what do we know about x to the power 0?
Yeah, it's 1.
Equals 1. So my answer is going to be 8. Awesome.
Dude, this is so easy now, but watching it is 5 minutes.
I was
did it like 10 minutes.
I was not understanding dy over dx in Jesus.
But we're good now?
Yeah.
All right, now you will find that this happens no matter what the coefficient is. So if your term happens to have just an x, all you do is drop the x. Okay, so the derivative of 8x is 8. I believe we've got some more examples here. Yeah, so this is true for any value of x. So the derivative of 3x would be, what would it be? 3, and the derivative of negative 5x would be negative 5. Trace me out. Do you want me to go back here?
Yes, please.
Alright, so when we're differentiating a constant term, so remember a constant term means it has no x attached to it. So in this case, the constant term would be this plus 4. The derivative of a constant term is 0. So in other words, it disappears completely. So if I were to differentiate this expression here, so we've got dy dx. Yulia, what would the first term be?
That would be 15x squared.
Nice. Jushna, what would the next term be?
It would be -2.
Nice. And then I just said the plus 4 disappears completely, so that's my derivative of that expression. Okay? So when there is a constant term, so there's just a number, no x attached to it, then it disappears completely. Okay? Now, the power of the term may be negative. Okay? The rules are just the same, but you have to just be careful here, because when we're subtracting 1 from it, it's going to become more negative. Okay? So here, if I've got y equals x to the negative 3, then dy dx would be, Swanee?
-3.
X to the power of 4. Nice. I think you said 1. I was like, oh gosh. No, that's not possible. Okay, we good? So the power came in front, the power is negative, so the whole term is negative, and the power became more negative. Now, linked to this is our work that we did on powers early on in the year. So, oh my gosh, we have to remember weeks back. If you have an expression that looks like this, okay, or if they have any of the terms that are in fraction form, okay, you can all see this is in fraction form. We have to change that term so it's not in fraction form and it's in power form. So we have to remember what to do with it. So I can say that this expression here, how else can I write 1 over x to the power 4? And remember that, oh nice! I like it. Thanks, Pete. So we've got 1 over x to the power 4 becomes x to the negative 4. Now notice, all I did here was write equals, because I haven't done anything to this other than rewrite it. Once I've done that, I would then go on to differentiate. I believe. Oh no, I haven't. So here, next to it, I can now say dy dx equals
-4x -5.
Oh, I'm loving it. Okay? So the first part, I've just written equals because I haven't done anything to it. Then I've written dy dx because I'm showing that I've differentiated it. Now, I'm saying it now 2 or 3 times. You're probably listening to me or hearing what I'm saying, but you're not really listening. So, because when you go off to do the questions on your own, you're going to just write equals in between all of them. Okay, please avoid doing that. Had I wanted to rewrite this back into the original format, how else could I do that? What would it look like? If I wanted to go back to looking something similar to this.
1 over 4x to the power.
Not quite. Remember, this negative 4
4 over
is actually not to the power. So it would be negative 4 over x to the power 5. Okay? Which I've probably given away a question that I was going to ask later on here. Yeah, that's annoying, isn't it?
Okay.
All right, so this example here, I would first of all rewrite. So I'm just x. Lovely, thank you, Olivia. This one here, what would I write?
4x to the negative 3.
Oh, she's on a roll. And this one here.
Would it be to be 5? This is 3x. Negative 3. Would it just be 3x squared? It's all like
Now, what do we want to move?
the 3x squared.
No, do we want to move the 3?
The x squared.
We just want to move the x squared. So actually what's going to happen is that this would be 1/3 x to the negative 2. Okay? Because just the x needs to move. And we can separate that. We can leave it, but the 3 must stay underneath the 1. And therefore it's going to be 1/3. Okay?
So basically you only ever want to move the x.
You only ever want to move the x. Yeah. Now, had this been in some kind of bracket, so if this had been 1 over 3x all squared, then you could have moved it. Okay?
And it would have just
But-
been this 3x squared.
And it would have been 3x to the negative 2.
But, oh wait, but was still one of the brackets though?
Yeah.
Because the 2 times
Yeah.
3.
Okay? But that is a different question. Okay? So once we've done that, once we've written them, let's carry on and differentiate them all. They're all y equals. It's a bit annoying, sorry. So dy dx. So Jennifer, what would this one be?
2x.
Almost
Negative 2x. Negative 2x.
negative 2x to the negative 3. Nice. Gladdy, what's the next one?
Negative 12x.
Lovely jubbly. And Ali. So you've got 1/3. And what are you doing to that 1/3? Mhm.
Negative 1 over 6.
Yes, negative 2/3. And then let's finish off for me.
X to the negative 3.
Lovely. Okay. Now, if you were ever not sure, you've got 1/3. You're multiplying by negative 2. Remember, the 2 is 2 over 1. Top times top, bottom times
I
bottom.
was just about to ask that.
Okay? So that's just a reminder. That's how we got that there. Okay.